O Espaço Aberto Ciência e Tecnologia de hoje é especial. Começamos em uma das instalações da IBM, aqui nos Estados Unidos, que reproduz o cenário de um dos shows mais vistos da TV americana. O Jeopardy, que começou nos anos 60, é um programa de perguntas e respostas um pouco diferente, porque os competidores recebem as respostas e têm que formular rapidamente as perguntas corretas.
This is Jeopardy, the IBM Challenge.
Há alguns dias, se a resposta apresentada fosse: é o computador que venceu seres humanos no jogo de questões mais complexo que existe, a pergunta correta seria: o que é o Watson?
Hello, my name is Watson.
Watson?
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
No programa de hoje vamos mostrar esse supercomputador, o Watson, e entender o trabalho da equipe que criou um processo de raciocínio que não usa neurônios, mas semicondutores. O Watson vai um pouco além da dimensão de uma máquina e se torna um novo competidor no jogo da vida.
Watson?
Who is Bozo?
Nice! Good job, Watson.
O Espaço Aberto Ciência e Tecnologia Especial está só começando.
Human language is very vague and ambiguous, and it's ultimately grounded in our experiences and in the world that we live in. We understand when each other talk most of the time because we understand what a race is or what a tree is or what a building is because we live in the world and we experience those things, and computers don't. So all they have are the words. All they have is the information. So the best we can do for a computer to understand human language is to try to give it the connections between words that can help it make sense of things.
Comprehension of the question. Analysis of whether you know the answer. Strategy of do I bet or do I not bet? It's a bunch. And a very, very short time frame. So when you guys started from ground zero, how did you solve all these problems? For instance,
well, when we first we agreed it was a very nicely formulated challenge. That's obviously not why they invented the game show, but it turned out to be a very nicely formulated challenge for a machine. But when we first started, we thought it was way too hard and we weren't going to be able to do it. But we decided to at least spend a year looking more deeply and in a more rigorous way at the problem, analyze it, come up with some initial ideas, and change the way we'd been doing research for the past 6 years to focus less on very small incremental results, which is how the scientific community generally works, and focus on a major result. Can we get significant improvement in the way we understand and answer questions within a year?
We mapped 4 different colors to 4 different levels of confidence. So green would indicate that Watson has a very high confidence level for this particular category, that he probably knows the answer.
Watson?
What is finger?
No, that is wrong.
But he's ringing in green because he had high confidence he should have gotten that right. He's saying, I knew this!
how does Watson think?
So Watson does not think the way a person does. Watson is a machine, and one of our first most important advances was to throw away ideas about making the computer work and understand language the same way people do. Watson often does not understand a question completely, but it breaks the question into a lot of different parts and analyzes answers with respect to different properties of a question. So it'll look at what type of thing is being asked for. What are some other words that are highly associated with these words based on just counting word frequencies in large, like the web.
Can you give me an example?
So how do you know who Ayrton Senna is? Am I pronouncing that? How do you? Ayrton Senna. So how do you know who he is? So you would have, over a lot of data, over a lot of passages and sentences, you will find a big correlation just by counting that a lot of times when Senna is mentioned, Formula One is mentioned, or auto racing is mentioned. So you learn from that there's a strong association between this word. Watson has no idea what it really means, but that name and these other words are associated. So, there must be some association between that and racing, and that and Formula One, and that and cars, you know, and going fast, and other words that it finds are mentioned more frequently.
All of this happening within 3 seconds.
Within 3 seconds. So what happens in the computer is that each answer Watson typically considers a couple hundred answers for each question. For each answer that it considers, it sends that answer to its own processor, to its own CPU, and there's thousands of them in Watson. And each processor is then just looking at this one answer and trying to gather evidence for that answer. So per answer, the computation takes 1 to 2 seconds, but each answer gets processed on its own computer in a sense. And then that takes about 2 seconds, and then all the answers come together again, and then all the evidence for each one is compared to the others, and we rank them to see which answer has the most evidence, and that answer becomes the top-ranked answer. And then we do processing to understand, when I have this much evidence for an answer, what's my confidence?
Watson's behind you. Watson will be the equivalent of how many computers that we have at home?
Watson is the equivalent of about 6,000 home computers. So Watson runs on a regular computer, just a lot of them, so that we can consider a lot of answers at the same time.
But not in the traditional sense of parallel processing, is it?
It is. It's called embarrassingly parallel. The computation that Watson does is embarrassingly parallel. It's actually...
That's the way it's called?
That's a technical term, embarrassingly parallel. It's so obvious that this can be done in parallel, because we take the work that Watson does for each answer is exactly the same for each answer. So we just take each answer, send it to its own processor, and then, you know, Watson's doing the same thing in parallel. If you could imagine, if you could think that, if a human could think that way, you'd be partitioning your brain up into pieces and having each piece try to figure out which is the answer. Of course, that's not how people do it at all, but that's how Watson does it. And the fact that Watson is doing things so much differently from how people do it really shows, not when it gets the answers right, but when it gets the answers wrong. So the mistakes Watson makes are almost always not mistakes that people would make. And that's because it's of the way it thinks.
The worst thing is if Watson just crashes in the middle of the game. That's what you don't want. But then the second worst thing is if you have some horrible bug where Watson starts getting everything wrong.
What are trousers?
No.
What is harness racing?
No.
What is taxi to the dark side?
No.
What is artificial sweetener?
Come on now. No.
What is milk?
No. Very nicely done.
We both beat them.
Good for you.
Humans.
In the process of development of Watson, were the mistakes the big driver of development?
Yeah, so we spent a lot of time from an engineering perspective looking at the errors that we had and analyzing why Watson got questions wrong and trying to develop approaches that in the future you're never going to get that one question again. So in the future, it would learn from the mistake. We, the developers, learn from that mistake and try to figure out more general solutions that would get that question right, but also get a bunch of other questions right as well.
14 years ago, IBM came out with Deep Blue, won a chess match with Garry Kasparov. But then there was not much use for a machine that can play chess. When you designed Watson, did you design already thinking of the usefulness of a machine like this?
We knew at the very start that the capability for having a machine that could understand natural language had business value. Every professional today has to deal with the problem of too much information, not enough time to deal with it all. So a lot of people are out there trying to do their jobs and aren't aware that there's some new piece of information that they might have used today if they had known about it. And almost all of that information is available in a natural language of some kind, not in the kinds of data that computers typically deal with and understand, but in English or in Portuguese or whatever your language is. People are writing, people are publishing scientific results, people are publishing lab studies, if you're talking about medicine, in the financial world, in the legal world. I mean, there's information. The vast majority of information is in human language, and we knew to begin with, and this is why it was our research agenda, that there's tremendous business value in trying to be in successfully processing that information.
What will be the future for Watson? Not in terms of application, but what will be the next iterations of this kind of technology? Will we see something like this in a much smaller platform, a laptop type?
There's a great scene in an old Star Trek movie. The fourth.
Scotty is always talking to his computer there.
So in the Star Trek series, they speak to their computer, right? I mean, they talk to it, they ask it questions, they tell it to go to warp 10 or whatever, and the computer just does whatever they say, but they say it. That was the idea that we had in mind when we built Watson. We want a computer that responds to requests and commands in our natural language, understands them, and gives us back what we asked for. In the Star Trek series, everyone's talking to the computer, and there's this, in the fourth movie, they go back in time to the present day, and Scotty sits down in front of a present-day computer. Starts trying to talk to it. And the modern-day people are looking at him. Why are you talking to the computer? That seems crazy to them.
Computer? Computer? Oh. Hello, computer.
I think we're not far away from computers that are going to make us forget we ever used these ridiculous devices, and we're going to be speaking to computers, and they're going to understand what we say. One of the main reasons that Watson was such a big and exciting advance is because we now have a much deeper understanding of how to make it possible to get computers to interact with us in our own language instead of forcing people to adapt themselves to what the computer needs.
Worst Actress of the Decade went to this celebutante for films including House of Wax and The Hottie and the Naughty.
What is Paris Hilton?
All right, here we go. Tweens watching this young man's video, Baby, on YouTube helped it to a record 260 million views as of summer 2010.
What is Justin Bieber?
Justin Bieber. I bet you're a fan, Watson. Good job.
Is it reliable?
It's very reliable. It answers. The most exciting thing for us about it is how good it is at estimating its own confidence. So when it gets an answer wrong, it usually knows it's wrong. So when during the game we got this now famous answer of Toronto for a question.
Right, that was Chicago.
Asked for, at least people understood the question was asking for a U.S. city, and Watson didn't really completely understand that that was the case.
Here is the clue. Its largest airport is named for a World War II hero. Its second largest for a World War II battle.
To a human, I think that's a very hard question to get wrong. And I'm used to seeing all three players nail very easy questions. So I get it right, then Brad gets it right. Watson only gets it wrong, but he names a city that's not a U.S. city.
What is Toronto? With a lot of question marks.
Now people look at that and say, wait a second, Toronto isn't even a U.S. city. Watson's not dealing with structured databases. It's trying to understand language.
Is it close to the human mind?
No, it's completely different from the human mind. It works. Everything Watson does is different from the way people do it. When a person sees a question, they understand. The first thing they do is understand the question. They're not even aware that they're understanding the question, but that's the first thing a person does. And often when a person hears a question, they know if they know the answer, even if they haven't quite gotten the answer yet. They'll say, oh, I know the answer to that, and they may think for a minute and then get it. Or I know when I'm watching Jeopardy on TV, the game is very fast, and a lot of time I'm not that great at it. And one of the reasons I'm not that great at it is speed. You know, I'll hear a question and I'll think, oh, I know, and then one of the contestants will give the answer, and then I'll say, I knew that was the answer. Watson doesn't work that way at all, so it doesn't know whether it knows the answer until it's got its answer. And it looks at its answer and determines a confidence because of all the evidence it's gathered for that answer. So its confidence is based on the strength of the quantity of evidence it's gathered for a particular answer. And it says, when I've got this much evidence, how often am I right and how often am I wrong? The show ends with these Final Jeopardy questions, which are much harder than the regular ones. You have more time to answer them, and you bet. You win or lose the game. Often you win or lose the game based on the answers to these questions. And the last question we got was about a 19th century novelist. And the question, I don't remember the exact words, but the question basically said, this author, so you know you're looking for an author, this author's most famous work was based on an account of something in Moldavia. So that was the question. Now the answer is Bram Stoker, who wrote Dracula. Right. The interesting thing, and people don't realize this, but what makes that kind of question hard for Watson is the question is actually giving you information about the book. So when Watson goes and generates all its evidence, it finds evidence for the book, but the question's not asking for the book, it wants to know the author of the book. So we call that a missing link. You are, and people do it very well, when they know the answer, they very well make these jumps, and that's extremely difficult for a computer to do.
You came up with what? Who is Bram Stoker? You are correct. Over to Ken Jennings now, and we find who is Stoker. I, for one, welcome our new computer overlord. Now we come to Watson. Who is Bram Stoker? And the wager? Hello, 17,973, and a two-day total of 77,147.
Stand up, stand up, stand up.
At that moment, it was just, wow, we won. It was just so much happiness.
It was these people who just, they did everything. I mean, no matter what I asked, no matter what I said to push on, you know, they did it.
Having Watson understand the question deeply enough to make that link, to make that jump from the book to the author and give the author as the answer was, that was a very proud moment.
Hoje o programa é especial. Estamos mostrando o mais recente popstar do mundo da tecnologia, o Watson, um supercomputador que hoje é uma celebridade por causa de um programa de TV. Mas ele tem sonhos de carreira mais sérios. Quer ajudar diagnósticos de pacientes ou ser uma mente excepcional no campo jurídico.
This notion of a massive amount of information that it's almost inhuman to try to remember all of it at once also applies to many situations, right? We talk a lot about the medical example, where it's inhuman to think that the whole medical literature will be at the front of the doctor's mind at the very instant that you describe this symptom or that symptom, right? One of the examples that I really like is you go into the doctor, you describe your symptoms. Okay, doctor starts thinking that might be this. Now, there's a bunch of other information, your history, your family history, test results, and all that literature out there, right? They don't agree. Some signal one diagnosis, some signal another. If you could objectively judge it all, right, and then say, oh, based on that, I think this might be the best diagnosis.
Other uses, not only medicine. What comes to mind?
In law, you know, you imagine this tradition of having an army of law clerks pouring through books or now online material, trying to find that case that provides precedent so that you could argue the case the way that you want to. We think that this is like the next step in how machines can help humans do higher level thought and do less and less of the mundane, which is kind of what computers have been doing all the way along, right? Even if you go back to punch cards. Obviously, we want to get some commercial benefit out of this, but it's also part of why a research division does this is because we're really trying to push that wall of what can you get computers to be able to do. Right now, Watson can digest a question and help you think through an answer. It can't think of a question itself. Could a computer do that in the future? Would it be useful for a computer to do that? Is there a way a computer could help us find our blind spots? You know, the question we didn't ask that we should have. So from a research perspective, this is a big step on a really long journey. I'm proud of the research team because they took a problem and they didn't solve it the way people had been solving it for years. They didn't just write more rules.
They went another way.
They went another way, and I think in doing so, really learned something about how we as humans think. You know? So I think the other thing that I take away from the whole project is amazement at what the human brain can do. Because this was very hard work to get a computer to be able to do one little piece of what humans do instinctively.
Watson, you have control.
Ainda existe longo caminho no desenvolvimento do Watson, mas a distância entre o raciocínio artificial e o humano está ficando menor. A cada acerto de Watson, os pesquisadores vibram, mas curiosamente eles vibram ainda mais quando Watson erra. É aí que se abre o caminho para o aperfeiçoamento. Esse é um momento de empolgação científica, mas também de reflexão sobre as consequências para o ser humano de mais um avanço desenhado pelo ser humano. Nosso programa se encerra por aqui, mas continua pela internet. Deixe sua opinião no nosso blog. O endereço é g1.com.br/globonews. Até semana que vem.